All right, so I'm probably violating my own procedure, which is to try to focus on and learn one thing at a time. If you throw in, several things that are new to you at the same time, it's probably you're probably going to have a bad time. But I think here I can actually manage it. So, what are the few things that I'm learning at the same time? One is Nim. It's a language I've played around with a little bit and really liked it. I was amazed at how quickly I could get productive. I generally am a big fan of statically typed, compiled languages. I've written a lot of, Java, Scala, Python, Kotlin, all of that stuff. A lot of Python in recent years. No hate for Python, but it's just, this is actually one of the selling points. It's just an extremely kind of boring language. For all I know, Nim is the same way, but the advantage here of Nim is that it is extremely fast and it's statically typed and compiled and all of that goodness. So that's one thing that I'm learning, and then I'm kind of using writing an interpreter as a way to learn it. But I'm actually learning how to write an interpreter at the same time using this book, Crafting Interpreters. And so that's going on. So this book, Crafting Interpreters, it goes through writing an interpreter apparently in Java as well as in C. The beginning of the book, I guess, starts with Java. I've written some Java years ago, back in my Android development days, and so I can read the language. I think anyone who can program can basically read Java, except for maybe some of the obscure parts. Especially in this kind of book where it's not even using like the newer Java, right? So there's the Java, whatever it is, 8 that introduced all of the, did make some positive improvements as far as like some of the more functional things with streams and whatnot. But anyways, this is like very straightforward Java, I think, the kind that you'd see in like university or whatever, where they use Java. So if I run into any problems, I think we'll figure it out. And then if that weren't enough things to be trying to learn at the same time, we also have Vim itself, or NeoVim in this case. So I've used, JetBrains IDEs for a long time. I can move around, like a ninja in them because I know um, all of the key bindings, and over many years I've perfected my key map, and the same key map applies across, IntelliJ, PyCharm, Golang, Rust Rover, DataGrip, um, all of them. I think I mentioned Goland, right? So these are all languages that I've used some more than others. But the point is that like there's basically a dedicated IDE for all of the major languages that has like the same shell as all the other JetBrains IDEs, and you can take your key map from one, export it. It might even automatically pick up the changes. I think if you have multiple of them installed, that actually might be wrong. I'm not sure. Point is, great IDE, but I still think that there are some efficiencies to gain from just, like I already am in the terminal with everything else that I do. I think, unlike a lot of other developers, kind of to my surprise that I've seen in recent years, they do rely on a lot of GUI applications. So I'm kind of surprised at like the level of developers who don't know how to use like move their way around Git, or even just basic like file editing or jumping around and moving between directories. Like they can't really use the shell or the terminal really at all. And so the point is that I would have a totally unified experience if I could just be completely in the terminal. And what's kept me from doing it is basically not really knowing how to use Vim very well, and never really taken the time to set it up so that I could actually have more than just like a plain Vim experience with no like syntax coloring or highlighting or jumping to definitions or all that kind of stuff. So I'm learning it. I'll be a little bit slow with that, but again, learning a language is not about like typing per se. Although, you could argue it's going to be some increased cognitive overload on top of trying to learn Nim and how to write an interpreter at the same time. But I think it'll be all right. If we find out that not, then fuck it. Then that it is what it is. But we're gonna jump in. So this book, Writing Interpreters, like I said, starts with Java, goes to C, and you're basically implementing. In order to do this, you're like implementing your own language called locks. The book goes through the language, some really basic things, what the language looks and feels like, the very basic features that it will have. Not really. We'll see what those are. I'm not gonna like take the time to go through the first chapter again that like introduces the language, but it is, the author goes out of his way to not make it like some crazy language that, you can't have like a book of this length and expect it to be developing some like insanely advanced like type system or even static, you know, static types or any of that. So like it's a dynamically typed, very simple language that can do like pretty minimal stuff, but obviously very valuable for educational purposes because you can write like a very contained small programming language and you can actually fit within the length of a reasonably uh, um, a book of reasonable length how to write an interpreter using that language. So that's great. So anyways, this chapter is the one that actually jumps into how you do all of this. And just jump right in. You see here it starts with all this, Java ceremony, public static void main, whatever. And this basically says, okay, so this is our interpreter here, right? This is the beginning of it. So if you give it more than one argument, print the usage, show that, you can't run this program called JLox in this case. Lox is the name of the programming language. JLox, I guess, is the interpreter itself, presumably because it's written in Java, whatever. So if you give the wrong number of arguments, print out the usage, exit with an error. If you give one argument, consider that to be the source file that you're trying to interpret, right? And then call this method run file with the path to the source file that you gave it. Otherwise, run a prompt, and this is nice. We're basically going to have a REPL, right? So a read eval print loop, which means we'll have some interactivity with this language. We can fire up like a shell, open up the interpreter by passing no arguments to our JLox program, and that'll give us basically drop us into an interpreter where we can write a line, press enter, and it will be interpreted by this interpreter that we write. All right, so we don't yet know what the implementations are for these things, run file and run prompt. So it starts with run file. Run file basically delegates to this other method, run. And all this does is it just reads the file, gets it as a string, right? In this case, it's an array of bytes, and then construct a string using those bytes with a default character set, whatever, and then call run. Run, we'll see what that does, but before then we have the run prompt, which basically just in an endless loop, it prints this little character, which is like, the prompt basically that you'll see there. It then reads a line. If you just press enter and pass nothing, right, that's where the line will be null. Then it breaks out of the loop. It breaks and then otherwise it actually runs the line, right? So the REPL just continues so long as you feed it these lines. All right, then we have run, which for now is just using this scanner. One of the things I've noticed right away is that things are just, in a language like Python and apparently even in Nim, there's just a lot less kind of ceremony around some of these things. I think Java is sort of infamous for having this whole crazy object-oriented kind of class hierarchy for the input stream readers and buffered readers. And so, like here, for example, you want to read from system in, you have to put that into an input stream reader, put the input stream reader into a buffered reader, whatever. I'm sure there are good reasons for that. Maybe not. Who knows? But we're going to see that, I was sort of not really surprised that when translating this over to Nim, which is going to be the part of this how I'm learning Nim, things are a lot simpler. There's kind of convenience methods for doing all this stuff. You don't need to wrap this into that and do all this kind of crazy thing. There, it's these sort of interfaces. As far as I know right now, and I don't really know a lot, they don't really exist in Nim, at least not in the same way, as far as I can tell right now. Right? They certainly don't exist in the same way they do with Java. The point is for now that we just have much simpler methods, right? So like, for example, reading the command line parameters, reading a line from standard in, you can see, peeking ahead here, what I've done so far, it's a lot more lightweight. But the amazing thing is, as opposed to Python and frankly, even relative to Java, the performance you get here from Nim is kind of insane. That's sort of what excites me about the language is like getting like close to or like much closer to C level performance in this kind of higher level language that is like a statically typed compiled language. That's just what excites me about Nim as the language. And you can see even just, if you just ran your eyes over and glanced over this Nim code that we have thus far, you will see that it is quite. What the hell did I do here? There we go. You will see that it is, you could really mistake it for Python. Obviously, if you squinted at it even a little bit closer, you'd see not, because you'd see like var and the statement and all that kind of stuff. But the point is, like, it's pretty light on syntax, which is really nice, you know. So like, even though it's a more advanced language and it has static types and all of that, it's not, you know, we're not looking at Rust here or Scala or even Kotlin or something like that, right? Like, it does have a much more kind of down to earth, light sort of vibe to it, for lack of a better way of putting it. It's obviously not very precise, but um, all right. So the point is, we said before that the run prompt as well as run files, right? So whether this interpreter is being fed a file or it's just a REPL, it delegates to run is where the actual substance of what we're doing to interpret the source is performed. And for now, all we're doing is we're just using this scanner, which is basically breaks up the input file, or really the string, breaks it up by into tokens, and then we iterate through them through the tokens. And for now, we just print, right? So obviously, there's more that we have to do than just printing, but that's what we're doing for now. And as the author says, it's not super useful yet since we haven't written the interpreter, but baby steps. All right. Anyways, we can look at the Nim that I've even written so far, which is just to translate this basic stuff over. And, you know, as you would expect with any programming language, there's quite a bit to learn here. There's a lot of concepts just in this small little program that we have so far, which doesn't really do anything interesting. So let's kind of take a look at that. Some of these things I, you know, don't even know yet, or maybe I knew it for a moment while I was initially writing it, have forgotten it. But this is the game, right? There's no kind of shortcut to learning a new language. You've got to kind of get your hands dirty, dig in, Google some things, do it repeatedly, and then before you know it, you're, you know, proficient in that programming language, or at least, you know, at least it's, you know, usable by you, right? Like you can get some stuff done. So starting from the top here, you see we have some imports. We'll get into this a little bit later, but we do have, you actually do have to declare, just like uh, the, uh, the definition or signature of your what are called procs, short for procedures, which we'll get into in Nim at the top of the file here. So we'd see that we'd actually run into a problem if, for example, if we commented this out and tried running this program, we would see that we are going to run into a problem here where, do this right here, right? So we get this error, right? In this case, I just ran I ran my program without any arguments. So this is Nim, this is C is compile, right? So compile it with verbosity 0. I wanted to specify that the binary that's output by the compilation goes into bin/locks. We do actually have that now, so you can see that this just got created. Anyways, the point is we got this error. What was this error? The error is that we have an undeclared identifier, right? So the identifier, that's the term I was looking for. The identifier must be declared. Let's see how the documentation actually says it. So nim proc, and this is what it tells us. An identifier is a symbol declared as a name for a variable, blah, blah, blah. That's not what I'm looking for. I'm looking for proc. So yeah, a procedural type is internally a pointer to a procedure. Nil is an allowed value for a variable of a procedural type. Whatever. It's actually not what I'm looking for. Probably want nim by example, procs. So it's got to have some detail here. Where is it? Nope. Where is this? I guess if we Googled for the error, that might get us something. So we have Nim Proc. Yeah. Okay, so I think I actually found this, and it is here. I'm going to add a new capture here for the application of Firefox. That's what we're looking at here. So, real quick here, it says that this is what I'm just looking at the actual manual, the official manual. What most programming languages call methods or functions are called procedures in Nim. A procedure declaration consists of an identifier, zero or more formal parameters, a return value type, and a block of code. Formal parameters are declared as a list of identifiers separated by either a comma or a semicolon. A parameter is given by a type name. So semicolon, type name. The type applies to all parameters immediately before it until either the beginning of the parameter list, a semicolon separator, or an already typed parameter is reached. The semicolon can be used to make separation of types and subsequent identifiers more distinct. So, all right, here they use commas. You can see you can do A, B, that's two formal parameters, both of type int, C, and D, both of type bool. And the return type of this proc, this procedure, is int. Here we have using, semicolons for visual distinction, right? So rather than separating these two groups of formal parameters by a comma, we're using a semicolon. And then here we have a problem because we have A, and then we've ended, I guess, the declaration of that formal parameter, and it doesn't have a type, right? Because, yeah, it's the semicolon stops type propagation. So in other words, you've broken it up. This int here won't apply to A, and everything needs to be typed, right? C and D are fine. B is fine. A is a problem. All right. Again, I'm really trying to get to this point about the way that procs need to be declared up front and when and why that applies. But so a parameter may be declared with a default value, which is used if the caller doesn't provide a value for the argument. The value will be reevaluated every time the function is called. So here we have an example. Proc foo takes a int, b int equals 47. B is optional, 47 as its default value. Parameters can be declared mutable and so allow the proc to modify those arguments by using the type modifier var. Did not know this, that's good. Returning a value to the caller through the second argument, notice that the function uses no actual return value at all, i.e. void. Okay, so that's good to know. This didn't declare a return type, so that means it's void. And in this way, since output is mutable, right, and it was declared as such, you can actually, in that sense, return. That's why they have it in quotes. You can return a value to the caller, right, because you've passed in output. You just give it like a 0, let's say, and then right underneath you, that gets mutated to the input plus 47. So effectively, this function is just like increment, but instead of actually like returning the value of the input plus 47, it's just mutating it right in place, and then bam, the variable that you pass to it will have been mutated. All right. If the proc declaration doesn't have a body, it is a forward declaration. This is what we wanted, right? If the proc returns a value, the procedure body can access an implicitly declared variable named result that represents the return value. So that's interesting, right? So if the proc returns a value, the procedure body can access an implicitly declared variable named result that represents the return value. Procs can be overloaded. The overloading resolution algorithm determines which proc is the best match for the arguments. So I think what they're saying here is that we never declared result, but that is implicitly declared, right? In other words, every proc has an implicitly declared result. And so here you can look at this as if it returned result. Even though we didn't we'll see later how you can return things, right, or what the output of a proc would be. There's both return, and then there's also just referencing it as the last statement expression. I'm not sure in the proc, right? But here, this actually does return result, right? The return type is char character, and the implicitly declared result we can access here, right? So we never declared this. So how are we able to even assign to it? But that's why, because there's an implicitly declared variable named result. Um, Here we go. Calling a procedure can be done in many ways. We can call it with positional arguments here, right? We can call it with named and positional arguments, right? Call me y equals 1, x equals 0, then do positional. We can call it with named arguments. So we have positional, named, and positional, just named. And then we can call it as a command statement without the parens even being needed. Man, I did not know this. That's pretty freaking cool. That is pretty cool. And we can see why this might make certain programs much more legible. Can't think of cases off the top of my head, but this can certainly come in handy, right? The fact that you can do it. I'm not saying you're going to always want to do that, but you can, it's not difficult to imagine how that might be useful for the legibility of a program. All right, a procedure can call itself recursively. Operators are procedures with a special operator symbol as an identifier. Okay, so it's a certain operator symbols. If you use them, certain symbols that you use makes it an operator. Right. So here we have $, and I guess we have to wrap that in these backticks. And here, this is just a procedure that converts an integer to a string. Here we're using quite a few things, right? This is saying we are declaring a procedure. It's an operator. It takes x int. It returns a string. And then we're also making use of the implicitly declared result and just calling int to string. So this is like, a way of just defining a kind of an easier operator that you can use rather than calling it int to string. And we can see what that looks like, right? So if we do this here, we can say nim secret. Apparently that's how you open the REPL. I read some old posts. It's because this is still not like stable, so it's called secret. I was hoping you could just like type nim or nim REPL or something and be dropped into this, but all right, it's a big secret. So let's see. Is there already a function that we have called int to string? Apparently there's not. All right, but sorry, that's int to string. We don't have it. All right. Point is that we could, let's see, can we turn something into a string like that? No. How the hell do we do that? Let's see here. Let's pull up ChatGPT. Nim int to string. What the hell? There should be an int to string. Int to string. Int to string. Type mismatch. Undeclared identifier. Do we need to import something? Let's search this. Nim into string. Dude, this is all the shit you learn. We might need standard / string utils. Is that the case? Import standard string utils. Int to string. All right, now we have it, right? Okay, cool. Echo. My favorite number is int to string. Cool. Actually, while we're here, we should check. Can we just do hello? this. Yeah, so it actually would do it automatically. Right, so you say let x string equal, actually that's for, we'll get to that. All right, point is, what the hell were we trying to figure out? Oh, we were trying to figure out how we can define a proc called $. It takes, what the hell was their example again? It takes an int, trying to figure out like the spacing, the kind of conventions here in style. So it takes an int, returns a string, and we say result equals int. We're basically just like aliasing and creating this convenient operator to do exactly what we just did before, right? So we know we can do this. Int to string. And then we can also now do, apparently, we can do boom. Yeah, pretty cool. And apparently we could also do this like this. We could also even do it like this. Maybe not. One dot. No. All right. Anyways, the point is you could see how it might be convenient to have kind of this shorthand operator notation to do something. We still didn't get to the part that I really wanted to see explained, which was why is it that we have to do what we're doing here up over here, right? So why is it that we need to like have this forward declaration? Really not sure yet, but I do know that you have to. Let's see if it gets into it. If a declared symbol is marked with an asterisk, it is exported from the current module. So that's nice. So we do have like a first class way of exporting symbols. So you don't have any of this, in Python or a language like that. It might be difficult to, hide things or have them be not exported. So here we can do that. For object-oriented programming, the syntax object.method name args can be used instead of method name object args. Parentheses can be omitted if there's no remaining arguments, like object.length instead of length object. Okay, pretty cool. So you can see here, abc.length, abc to upper, a, b, and c dot card, standard out right line. How they introduce this? Sorry, this method call syntax is not restricted to objects. It can be used to supply any type of first argument for procedures. Another way to look at, what is it? Can be used to supply any type of first argument for procedures. Oh, I see. The point is, even string, which apparently is not an object, you can still do that, right? The method call syntax of thing.method isn't restricted just to objects. Another way to look at the method call syntax is that it provides the missing postfix notation. The method call syntax conflicts with explicit generic instantiations. P of type T, X can't be written as X.P of T because X.P of T is always parsed as X.PT. Okay, whatever. We'll get to that if we need to. All right, this is now a new thing about properties. Nim has no need for get properties. Ordinary get procedures that are called with the method call syntax achieve the same, but setting a value is different. For this, a special syntax is needed. Type socket, this is apparently exported. It's a ref object of root object. Host int cannot be accessed from the outside of the module. Wow, pretty interesting. Oh, so even though you have this type socket and one of its attributes or fields, I don't know what they're called, is host, you actually can't access that outside of the module. Pretty cool. This, I guess, was the point here, that you can have a setter a setter that is exported, right? And you have to do this like host equals thing. All right. Whereas the getter has no special, right? You've created this publicly accessible getter just by declaring proc host with the export marker. And so, right, so a proc defined as f equals with the trailing equals is called a setter. A setter can be called explicitly via the common backticks notation. Interesting. The setter can be called explicitly via the common backticks notation. Oh, interesting. Okay. F equals can be called implicitly in the pattern x.f equals value. If and only if the type of x does not have a field named f, or if f is not visible in the current module. These rules ensure that object fields and accessors, okay, whatever. I just wanted to see about the declaration. Is that anywhere? Is there anything in here about like forward? Forward. Future directions? No. Hmm. All right. Whatever. Hopefully we'll find the actual documentation on this point. But the point is that back there in our program, we know that we are going to run into some problems if we don't first up here, right, declare these, right, have these procedure declarations. All right, good to know. So now where were we? Point is, we're trying to translate the Java that we've seen so far, which is just the beginnings of this interpreter, into Nim. So we start here. We have these imports. We have this these proc declarations we went through. Then we have when is main module. So this you have to assume is equivalent to what you might see in Python, where it's if, underscore underscore name underscore underscore equals main. And again, that what that does in a language like Python, you'll see that in scripts or Python source files that's used to check whether the current Python module is being run as the main program or if it's being imported, right? Because you may have code that you don't want to run just when that file, that source file, is being referenced as an import, right? You only want it to be executing something that is your program when it's actually being called as a program. So that apparently we have the equivalent of that in Nim. And let's quickly look at documentation for Nim when is main module. And let's see if we can find it in the docs, is main module. So this is a system const. And okay, it's true. What it tells us here is that it is true only when accessed in the main module. This works thanks to compiler magic. It's useful to embed testing code in a module. Okay, I guess the other part that we're seeing here is how to do this Boolean test, right? So we have when, if the search would work, that would be fantastic. Okay, back here, when. Can we get some explanation of when? I guess this might be on the Boolean type. While, is there a when? When? Oh boy. Let's see, Nim, when keyword. Man, here it is. The when statement. Interesting. Nim VM. The when nim VM statement. The when statement. The when statement is almost identical to the if statement with some exceptions. Each condition expression has to be a constant expression of type bool. The statements do not open a new scope, right? The statements that belong to the expression value that evaluated to true are translated by the compiler. The other statements are not checked for semantics. However, each condition is checked for semantics. The statement that belongs to the expression that evaluated to true. So here it's, let's say int was 2. So this would be the statements that belong to the expression that evaluated to true. The other statements are not checked for semantics. But each condition is. I'm not exactly sure what this means right now. I don't care to go into such detail at this point, but interesting. The when statement enables conditional compilation techniques as a special syntactic extension. The when construct is also available within object definitions. Oh, interesting. So that actually is kind of important, right? Is that it's saying, so we have here, I see. So their example is actually illustrative, right? So they're saying here, right? It's like if this expression evaluates to true, then the statements that belong to this expression get translated by the compiler. The other ones just don't. Now the conditions themselves are checked for the semantics, right? But the full statement won't even be checked for semantics. I think that makes sense. Let's see if ChatGPT has anything further to add on this. When statement in Vim. When versus if statement in Vim. Not Vim, Nim. I'm not doing Vim. Oh, that's really funny. So in Nim, both when and if are used for conditional execution, but they serve different purposes and have distinct use cases. Okay, I'll just add my my screen here. What am I looking at here? This is ChatGPT. Just show you what I'm looking at here, right? So in Nim, both when and if are used for conditional execution, but they serve different purposes and have distinct use cases. The when statement in Nim is used for conditional compilation. It's evaluated at compile time, and code blocks within when statements are included or excluded from the final executable based on the condition. It's typically used to conditionally include or exclude code depending on compiler flags or build configurations. Example of a when statement: when defined release build. Right. So it's sort of like pragmas, or whatever you have in other languages. So you have if defs, right? Like if defs in C or C++ or whatever. So okay, conditional compilation. So in this example, the code within the when block is included in the build only if the release build symbol is defined during compilation. But the if statement is a runtime conditional, right? That's like the just normal kind of Boolean if check that we're used to thinking about. It's evaluated during program execution. The code blocks within if statements are executed based on the condition at runtime. It's used for making decisions and branching the program's logic during execution. An example of an if statement: let x equal 5 if x is greater than 0, echo x is positive, else echo x is non-positive. In this example, the code within the if block is executed because x is greater than 0. So that's the main point here, that when we do when is main module, that's conditional compilation, and that actually occurs at compile time. And then I guess what that means is that it actually turns out that the entirety of this when is main module, right? Uh, this entire block um, over here won't even be included in the compilation if this evaluates to false. Okay, interesting. Although I'm not 100% sure what that really means though in the case of like a program here, because don't you not know whether it's being used as a program until the point at which you're uh, running it? No, I guess not. That is a little bit confusing, right? Because it's like as opposed to what? As opposed to when you're importing. So I guess that's the point. Is like at compile time, when you reference this nim source file as an import, right? The compiled unit as it exists in the context of the import doesn't even include this whole block. It's not that like at runtime it conditionally just the import so to speak executes and then this conditional evaluates to false and so it doesn't run the block. It's like this entire block as far as the actual compiled unit there just isn't even included, and it's only included from the standpoint of in the binary or in the compiled output in the context of the thing that you actually run, like the program that you run. All right, in any event, we're getting really far afield in some ways. So, point is back to this whole interpreter thing. So we went through. We have these few methods in Java, and we've translated them over. So how do we do it? Well, we start with this let statement again. So that's single assignment as opposed to var is let args equal command line params, and this is defined over here in the standard library command line.nim, and it says here that this is a convenience proc, a convenience procedure which returns the command line parameters. So that's great to know. And okay, so we get the args. We're gonna have that then, and you can see here I put like a little echo as I was kind of debugging, and we just did a direct kind of translation from the Java. So if you're calling this program incorrectly because you haven't given it either no arguments to run the REPL or a single argument, which is the path to the source file, then echo, we really should here print the usage. So how did he do it in the book? Let's just kind of follow his example. So we want to print usage jlocks script. Okay. So that's good. And then otherwise, if the args length is 1, then we call this method run file, which we defined right over there. All right, we know this. And how the hell do I get rid of this split now? Okay. We call run file passing the path. Otherwise, right, else we run the prompt. Okay, so what does run file look like? Run file simply calls read file. Read file being a procedure that exists in the standard library sync.io. Takes a file name. Now we actually understand some of these things that are going on here, right? So we have a proc declaration, which is exported. That's how we can even access this. It takes a file name, which is of type string, and it returns a string. And you can see the documents just say opens a file named file name for reading, calls read all, and closes the file afterwards, returns the string, raises an IO exception in case of an error. If you need to call this inside a compile time macro, you can use static read, blah, blah, blah. All right. This part here, this part of the syntax here, we don't actually know what any of this means yet. But that's going to be quite interesting. So we have tags read IO effect. Maybe we should look this up now. It's kind of an interesting thing. Tags read IO effect. So nim proc tags. let's see. Wow. Wow, wow, wow. This is quite, quite interesting. So, wow. Exception tracking is part of Nim's effect system. Raising an exception is an effect. Other effects can also be defined. A user-defined effect is a means to tag a routine and to perform checks against this tag. So here they have an example. We declare a type IO, which we're going to, I guess, use just below it as a type of an effect. So we have this proc declaration read line returns a string, and then it's tagged with IO equals discard. We don't know what that means yet. The other one here, right? On the other hand, right, conversely, we have no effects, please, is tagged with nothing, right? So this is apparently a list of effects that you can tag your procedure with. And this is amazing. So you can't actually do this here, right? Because since readline itself is tagged with the IO effect, you cannot, from a proc that doesn't declare that, do this. So that's amazing, right? So it gets tracked throughout the calls, and you can't just stuff into your procedure a call to another procedure that is tagged with that. If the thing you call is tagged with it, then so is yours. Amazing. A tag has to be a type name. A tag's list, like a raises list, can also be attached to a proc type. This affects type compatibility. The inference for tag tracking is analogous to the inference for exception tracking. There's also a way which can be used to forbid certain effects. Here we again, IO, read line tagged with IO, echo line, void, discard, no IO please, forbids IO. This is okay because it didn't define any tag. Echo line, right? Echo line didn't have any tag, but we couldn't do this. We couldn't do this because readline is tagged with IO. The forbids pragma defines a list of illegal effects. So I actually don't know. We should probably start with the beginning of the effect system. This is really where we need to start. The rules for effect tracking change with the release of version 1.6 of the Nim compiler. Exception tracking. Nim supports exception tracking. The raises pragma can be used to explicitly define which exceptions a proc or iterator or method converter is allowed to raise. The compiler verifies this. Man, this is powerful stuff. Here we have a procedure, takes what, a bool. We then say, we use the raises pragma to say it raises IO error or OS error or both, I guess either or. So if what is true, if that evaluates to true, raise an IO error. Apparently there's this new exception proc. That's how you can like raise an exception. You wrap the exception type okay with this message, I guess. Otherwise, raise new exception OS error OS. I don't know if this is just like some custom, just an example, or this is actually built in. Let's see. Can that be done? I don't know. Well, all right, anyways. An empty raises list, in other words, where it's just raises empty list, means no exception may be raised. Try unsafe call, blah, blah. So this is not allowed to raise an exception. And I guess we're not doing that because we are, in fact, using a try except here. We're using a try except. So we make this unsafe call. We have the implicit result. Set that to true, set it to false in the case of an exception that we catch. Okay. So, right, we couldn't just raise. We couldn't just raise this. A raises list can also be attached to a proc type. This affects type compatibility. So here we declare a type callback. It's a proc, takes S string, raises IO error. And then we say there's a variable of type callback, C. And here we have proc P, takes X a string, raises new exception. Okay, raises new exception. So now if we try to assign P to C, that's a type error. That is a type error. For a routine P, the compiler uses inference rules to determine the set of possibly raised exceptions. Oh, I see. That's the problem, right? Because proc P, wow, raises an OS error, but we declared callback as proc that raises IO error. So therefore, this does not even type check. It doesn't type check to assign P to C, right? Since P raises OS error and not IO error. That's pretty unbelievable. Wow. That is really freaking cool. For a routine P, the compiler uses inference rules to determine the set of possibly raised exceptions. The algorithm on P's call graph. Okay, they go through the algorithm. All right. Maybe worth reading. Every indirect call via some proc type T is assumed to raise system.exception, the base type, and thus any exception, unless T has an explicit raises list. I see. So um, you actually have to like constrain it. You constrain it through raises. Without that, it's assumed to raise any exception. But if the call is in the form of f, blah, blah, where f is a parameter of the currently analyzed routine, it is ignored. Sorry, how do you read this? However, if the call is of the form f dot dot dot, where f is a parameter of the currently analyzed routine, it is ignored. That is marked as effects of f. This sentence doesn't seem correct, just grammatically. If the call is of the form f dot dot dot, where f is a parameter of the currently analyzed routine, it is ignored. Yeah, that's not right. I should raise an issue here. Hold, please.